Okay, welcome back. This is going to be, I guess, the second chapter in this series, and possibly the final chapter. I'm not sure how much more I want to do with this before, um, I guess, before switching gears a little bit. So for this section, what we're going to do is we're gonna pick up kind of where we left off, but we're going to go cover some much more advanced topics. The first thing that we're going to look at is creating a new database called NASDAQ. Uh, we're going to use NASDAQ. Uh, Go ahead and create some schemas. So I've created a staging schema, uh, staging inserts, staging updates, staging deletes, and then fact. So it's not necessarily mandatory to have these different schemas, but for myself, I like to use these um, for organizational purposes. Now, if you remember from before, we had a really simple table for our stocks. So we're actually going to start over fresh and do this more the way that you actually do it in a true environment. So before, what we were looking at was just making sure that we could schedule a job and bring in Python data from an application to a flat file, and then from that flat file on a nightly basis, bringing that into SQL Server. So the unique thing about that before was just making sure that we had a live data source streaming into our website or into our, sorry, a live data source streaming into our database. Um, Now that we've kind of gotten over that hurdle, we're going to look more at the actual database itself. So we're going to create this table, and you're going to notice a few things that are different from before. The first thing being that we're actually going to use a primary key on this. Um, so what we're doing is we're just going to have an integer key. So it's just basically a 1, 2, 3, 4, 5 like that. This identity means that it's going to start with the number 1 and it's going to auto increment by 1. So we won't even have to do anything. So what we'll do is we will insert these columns right here, these three, and then our stock ID, that's automatically going to be populated. When we populate a key being primary key, unless otherwise specified, this is going to create a clustered index on our table. And this is going to be the name of the clustered index. It's going to be stock ID. Additionally, so this, if you recall, this stock date time, this comes from Python. So this tells us when the row of data was actually captured by the Python script. Now this row right here, this is a date time too. This has a default value of get date. So get date is basically the date and time, like the timestamp um, of when this row is inserted into the table. So stock date time was basically when we capture the date, or when we capture the stock value, and this load date time is when the value is actually inserted into our database or into this table. And again, we don't have to do anything with that. That's going to happen automatically for us. Um, Another thing that's cool is this is going to be a temporal table. So with the temporal table, we can see basically the lifespan of a particular row. So if we have a row and we decide for whatever reason to change it, delete it, insert a new row, we're going to capture that. Um, and so there's a few things that are really important with that. We need this column here, sys start time and sys end time. It's going to be a date time too. We need to have it being generated always as row start, and this was going to be always as row end. It can't be null. And then we're going to have this other line here that says period for system time. And then it basically, so these two things right here, they can actually be other names besides these two. This is just kind of the standard convention. But whatever these two are, you need to have those corresponding down here, if that makes sense. And then what's going to make this a temporal table is we have this statement down here that says with system versioning on. Now this part right here, this history table equals dbo dot NASDAQ stocks underscore history. That's not mandatory. We don't have to do that, but I like to go ahead and name it. Otherwise, it's going to have some like funky number underneath it, It's just going to be something that will be kind of hard to see. So if we come over here uh, to our NASDAQ database and we look at our tables, we'll see this DBO .NASDAQ stocks, and we have this little like it looks like a clock function there. It says you can tell it's like telling time, but that's our history. It's saying that it's got a temporal table attached to it. So it has this is the table that we just created with it. This is the history table over here that you can see. So it's going to be pretty much identical to our stocks table. I mean, there is going to be a few differences that I don't really feel like getting into right now, but basically you can query this table to see when changes were made and basically to see what the lifespan of the table was. Um, and you won't really see anything with that too much right away, but once you start making changes to the data, you can go back and query that later. Now, honestly, we're not even going to really use that function too much in this tutorial, but I think it's good to have that on every table if possible, every kind of production style table. This is more like on what you'd have like on the OLTP side, but what we're focused on is more data warehousing. So we're going to move on. Basically, I just want you to have a better table to work with. Next, we're going to go ahead and create just an initial staging table. This is where the data is actually going to first touch our database. So it's going to go from the flat file, to this staging table first. So again, you can see there's only 3 columns here, and we're just having this as a varchar 75. That's going to be plenty big enough for anything that we're going to see. I think our longest stock name is like 13 characters maybe. I think stock price also is like 13 characters or something. Stock date time, I can't remember what that was, and I know it's less than 75 in length. Let's see. So this is just a good note. Like later on, if you ever want to like alter your tables, just a lot of times I forget what the syntax is, so I like to keep these little notes handy just in case when I'm playing around. But you'd alter the table and say the table's name. I probably should have said make sure that this has a DBO in front of it, since I'm playing around with different schemas. I also noticed this, something interesting to mention. This file has been saved. I've actually named this one NASDAQ project.sql. And so you can see that it's green, but since I just made a change, this is yellow. If we go ahead and save that, it's going to go back to green. So that's kind of a cool way to see what you've changed. Let's see. Inspect the table and temporal table. Okay. So this is basically, right now we don't have any data in here. It's 9:42 right now, so my the Python package is set to go off at 10 o'clock. And then again, the SSIS package is set to go off at midnight. But you can, just the way we queried the NASDAQ stocks table, we can also query this history table. So if we query both of those at the same time, even though there's nothing in there, you can see that for the most part, they pretty much look like they're identical. So we also, this is what we're really getting into with this section of the tutorial, though, is getting into change data capture. So I think when I was talking to you about the fact that you're going to have large amounts, even though with this example 7,000 rows is not very much, in general you're going to have large amounts of data that are going to be transferred to your warehouse on a nightly basis. And so rather than truncating your entire data warehouse and bringing in all of the data that's been added to your OLTP database, you only want to bring in, you basically want to speed the process up. So there's multiple ways you can do that. One way is to only bring in the new data or the changes, to be more precise. So when I say changes versus new data you would think of like inserts, and change data would be you want to account for inserts, updates, and deletes. But those are the things you want to focus on, are just those things that are different. There's no need in duplicating your data. For redundancies later on, for things like making sure that in case of an emergency or disaster, you can recover your data. That's one thing, that's storage. But uh,